Yes? Yes? Ah, the classic. The vise was slightly damaged. All right. I'm on my way. I'll be with you at the machine in a minute. Bye. As you may have noticed, our apprentice unfortunately slightly touched the clamping device with his milling cutter and now wants to know whether his spindle got a bit damaged. For that, I've brought along a cool tool to help us check it out properly and quickly. Yes, much better. Here's the good stuff, our PSC case, which stands for Portable Spindle Control. What do you do with it? We can check our spindle through various measurements, monitor the runout, vibrations, and much more, but we'll dive into all the specific details a bit later. What does the case include? Naturally, it contains the main component of the system, our LC50D-IGILOG. Of course, we need power supply through an adapter. We've integrated our interface directly into the case. All the necessary cables are already provided. The software is included as part of the package. I simply install them on my laptop and can analyze, record, and document everything independently of the machine without needing any external help. But we'll see that in a moment. Now let's set the whole thing up. The system is now fully and completely set up. As we've clearly observed, I securely mounted the laser onto the machine table using these two magnetic feet. It's really enough to use your eyes. It's not an exact science. I don't have to measure it with a dial gauge. It's really enough to do it by eye. Another special feature here is the flat ribbon cable. I need it to route the cable out of the machine, which allows me to work even when the workroom door is fully closed and ensures full operational functionality without crushing the cable. What we're going to need next here is our reference tool to move forward. We are now installing the reference tool in the machine so that we can then carry out our measurements on it. Now we are ready to go and can start taking our measurements. What we need to do now is set up a job in the LC Vision PSC software. Then we carefully position ourselves with the reference tool directly in the laser beam. The software guides us to ensure that we have positioned everything correctly. Then we carry out the job. In order to obtain an overview of the overall condition of the spindle, we will gradually carry out all possible measurement tasks. This helps us get a clear and detailed visualization of the overall picture, and we're doing that right now. I'll begin by starting off really simply with the radial run. I'm assigning an arbitrary job index here. I will give one arbitrary job name. Then I define my parameters. What I want to do here now is I want my speed range from 1000 RPM to 10,000 RPM, which corresponds to the maximum speed of this machine. In other words, I want to know at which speed I have the worst concentricity. And I define that here with 1000-step increments. That means I start at 1000 revolutions and increase by 1000 revolutions each time until I eventually reach a maximum speed of 10,000 revolutions. That's it. Now we can get started. For those of you who are lazy about writing and don't want to type in the speeds on the machine, I have something else for you. So we can generate an NC program for this specific job. You can easily select your preferred control system right here at the top. It's all ready and set up for you. You can copy this code to the clipboard and paste it into an NC program, or you can decide to save the entire thing as a file and transfer it via USB or even over the network connection, depending on the connection you have available, onto my machine. I've already taken care of that and I'm now making my way over to the machine. As you can see here, I've already roughly pre-positioned the reference tool in place. Right now, I'm starting up the job that I've just set up a moment ago. I am also being guided directly by the software here, as is the case now. Set the spindle speed to 1000 revolutions, which I now also do in the single block. Then I say finished. And receive a control panel here, which provides detailed guidance to accurately position my reference tool within the laser beam. Once I have done that, I can confirm the whole thing. And then the measurement begins. As soon as the measurement is complete, I receive a notification to increase the speed to the next level. I did that again in single mode. I set the speed to 2000 RPM, confirmed it in the software, and the measurement started. And now I went step by step through the entire process up to 10,000 RPM. I need the machine for this. Or rather, I only need the machine to push through the speeds. Everything else, the evaluation and the software, runs independently of the machine. To give you a clearer understanding of how sensitive the whole system is, let's carry out a very basic test. I started a job and then we just introduced a slight vibration to the machine. As we can see, the measurement is now running and I'm just going to give the machine a little tap. And we immediately see a spike in our software. We repeat the whole process again. So, and there we have the next spike. This is just to give you a clearer sense of it once again. How sensitive the whole thing is. Don't just look at the machine or the spindle, but perhaps also consider including external influences, such as an overhead crane that moves over your machine during the process, or a forklift driving behind your machine, potentially causing vibrations. All of that can lead to influences on the spindle or even get reflected back to the surface of the workpiece. And this just shows again what to consider in a spindle analysis. So it's not enough to simply carry out a basic analysis of the runout, the thermal stability, or any other measurements. You always need to consider the entire system in a comprehensive manner. Our measurements are complete. We have collected all the data we need for evaluation. We will now pass these as a detailed report to our expert. He'll carefully evaluate the whole thing once more and let us know if our spindle is still in good shape or if it's completely worn out and should be replaced. We have now recorded the current status of the spindle, but who knows what will happen to the spindle in a few weeks or even months. Therefore, I would always recommend that you take regular measurements at consistent intervals to effectively monitor the spindle's progression, document its changes, and collect valuable data over time efficiently, to effectively counter an unplanned machine shutdown and minimize potential production disruptions. This saves you time and, of course, costs, which is very important. Remember, always stay process safe.